Good morning, students. Today class we are going to discussing about the second method under continuous random variable is non-monotonic transformation of continuous random variable. In this topic we can able to defining that how to changing the more than one random variable to the single random variable. In last session you can see that is only some monotonic transformation. In monotonic transformation is only applying on one-to-one conversion. So one random variable conversion to another random variable is a single. But here it's a non-monotonic transformation. It is able to changing the more than one random variable to single random variable. We can obtaining the mathematical relation of non-monotonic transformation. We have to using the basic conditions of non-monotonic transformation. First of all, the condition of the transformation is we can generally writing the function is y is equal to transformation of x. Any random variable you can change it to another random variable. We can able to applying the transformation on random variable x. It is giving that y random variable. But in case of non-monotonic, already the name is indicating it is a non-monotonic. Non-monotonic. In this non-monotonic transformation means the more than one random variable we can able to change into another random variable. We can obtaining the relation for this. Here I am consider the assumptions. In this my first assumption is here x1, x2, x3. The x values are x1, x2, x3. These three are the elements is relating to random variable x. Here I am consider more than one random variable or more than one event is relating to one random variable. Here I am consider random variable x. For this I am taken three events. Those are x1, x2, x3. These three values I can change into the another random variable y. The changing, whatever the change you can obtaining on is another random variable. Here I am taking that the event of that is y naught. Here my assumptions are the first one is I am taking the more than one event in a random variable x, and second one is I am taking the output. Output means the another random variable event is y naught. Here I am writing these two quantities are equal. These two quantities are equal. Why? Because what are the input you can applying the same output, the same quantity output we must obtain here. But the conversion can be changing, but the quantity is not change. Here I am using this random variable capital X. Events are three. Those three events I have to using here condition. The condition is we can able to changing to single random variable. For this I am writing the equation is probability of capital Y less than or equal to y naught is equal to the probability of x at y less than or equal to y naught. Is just it can representing the conditional probability. This one is the normal probability of y. Now we can replacing the corresponding elements. This function belongs to the fundamental notation of distribution function. That's why I am representing the capital Y of y naught is equal to integral the x given y less than or equal to y naught. This can representing the three events is relating to random variable x. Now you can represent the density function of x is fx of x into dx. Just I am representing how many values I am taken under random variable x. Those values I am representing in mathematical notation. Now you can writing the corresponding elements. The corresponding elements here I am writing here already what are the relation you can obtain in a monotonically transformation. The same you can utilize in here. But the only change is In monotonic transformation, you can able to changing one random variable to another random variable, but in a non-monotonic, the more than one random variable or more than one event in a random variable can be changing to another random variable. For this, here I am taking the graph. This graph is representing the fundamental relation between y and x. Here the transformation I am taking on y-axis, and the input or a what are the change you can doing on the random variable. Here I am representing on horizontal axis. X is a given random variable, y is a required random variable. Here axis I am taking the three quantities x1, x2 and x3. These three quantities, what is the values we are having, those values you are finding by using the non-monotonic transformation technique. For this graph, just you can take in that any shape, but on that shape you can representing x1, x2, x3. Why? Here I am consider three events. These three events I can able to changing to y by using the transformation technique. Here these three events I am representing in this notation. Now I am directly writing that for each and every event we are having the transformation is fx of x1 that dx of dy naught. It is high in the modulus condition. Already we are seeing this condition in monotonic transformation. But here more than one value is available. But each and every one is high in the individual representation. The individual representation we are writing here. We can't do the any separate derivation part. Just you can utilizing that what is the derivation value you are obtaining in a monotonic transformation. Those are represented here. One more thing is you can adding these quantities. The final value it can representing, it is a non-monotonic transformation. This entire collection we are representing is fi of y is equal to summation I is equal to 1 to n fx of xi is a modulus of dxi divided by dy. Here you can simply remember the more than one random variable or events you can able to changing to single random variable. You can using the non-monotonic transformation. Here only the difference is we can adding the number of quantities in a non-monotonic transformation. This is the complete non-monotonic transformation derivation part. Now coming to the problems on the transformation techniques and how he is asking the problems on these transformation techniques. First, I have to give an example for this. Show the linear transformation of Gaussian random variable. Gaussian random variable is produce another Gaussian random variable. Just is asking the statement. The statement is show that linear transformation generally is asking the problems in this orientation in this transformation techniques. Here what is asking that show that the linear transformation of Gaussian random variable is produce another Gaussian random variable. We can obtain this one. Here you can take in that the linear transformation equation. Now here I am writing the linear transformation equation is can gain the solution for this. The linear transformation equation already we know that the linear transformation or the linear equation y is equal to ax plus b. From this we can obtain the x value. How to get in the x value? ax is equal to y minus b. From this, x is equal to y minus b divided by a. We can differentiate this equation with respect to y on both sides. On both sides, here I can make the differentiation. Why have to make the differentiation? We can able to changing one random variable to another random variable. We must having that its density function and its differentiation value. That's why here I am doing that. The differentiation of this quantity both sides with respect to y, differentiating on both sides with respect to y. By applying this one, you can writing the dx divided by dy is equal to, here only the y is a variable parameter, a, b both are constants. That's why we can writing this quantity is the dy by dy, the value is a 1 divided by a. Here you can obtain the x quantity as well as dx by dy. Y, we are having the formula is fy of y is equal to fx of x into modulus of dx divided by dy. By using this formula, you can simplify this one. But how to simplify this value? Here, what about the density function? He is given any density function in a given data? He is not given that. He is just mentioning the Gaussian random variable. Here he is given the clue is Gaussian random variable. For Gaussian random variable, the density function is fx of x is equal to 1 divided by square root of 2 pi sigma x square into e power minus x minus m whole square divided by 2 sigma x square. This is the formula we are having for that. By using this Gaussian density function, we can able to simplifying the given random variable to the required random variable. Already we are finding the x value. Where the x value is there, you can just substitute in the x quantity in that term. Okay, in this equation, we are finding the x value from a linear equation, and we can also finding the dx by dy quantity by differentiating the linear equation with respect to y. Now you can finding the quantity of fy of y by using these two quantities is a density function of Gaussian random variable and the dx by dy quantity. First of all, I am writing the fy of y is equal to the density function. Already we know that the function I am writing here is 1 divided by square root of 2 pi sigma x square into e power minus x minus m whole square divided by 2 sigma x square. Into the dx by dy quantity. Already we are obtaining the 1 by a value. That's why I am substituting the quantity of 1 by a here. You can writing this entire equation in terms of y. X quantity is replacing with the y minus b by a. In this equation, I am changing the quantities. The 1 divided by square root of 2 pi sigma x value I am changing with is y minus b divided by a here sigma square. Similarly, you can substituting in the power of exponential minus x quantities y minus b by a minus main value m whole square divided by, here you can writing the 2 sigma is a y minus b by a square. Here you can simplify these quantities This entire value is multiplying with 1 by a. Now I am writing this above equation is 1 divided by square root of 2 pi sigma y minus b divided by a square into e power minus, here you can take the LCM for this. These two are having the LCM is, this denominator is a 1, here it is a. You can take the LCM for these two terms is a value is divided by a. The quantity is y minus b minus am whole square divided by 2 sigma y minus b by a square into 1 by a. Here I am writing this is 1 by a in a square root of 2 pi sigma x square. This entire quantity I am multiplying with a square. Just I am moving this 1 by a in root. Just I am writing under root. I have to keep this a value. That's why I am writing the a square quantity. Now I am writing the one more step for this. That one is the 2 pi a square sigma so y minus b by a square into the exponential term. Here you can take the common term is a square. Already denominator is high in the a. You can take in the separate from this bracket, otherwise you can write in the bottom of this one. You can write in this a term in a denominator. You can writing minus y minus, here I am taking the minus is a common. The remaining terms are the b plus am totally high in the whole square divided by, already the denominator is a square quantity. The a square quantity I am writing here the 2 a square sigma square y minus b by a. For our simplicity I can move this a term to denominator of this entire term. Now here I am consider some assumptions. The first assumption is a square sigma y minus b by a square. This entire quantity I am treating sigma y square is equal to, here you can write in the let a square into sigma y minus b by a square. The first assumption. Coming to the second one. The second one is this quantity is a b plus am. M is belongs to x term. This quantity I am to consider the mean value of y. The mean value of y is my is equal to b plus am. These two values you can representing in this one. Finally you can writing the fi of y is equal to, just you can substituting the corresponding quantities, 1 divided by square root of 2 pi. This entire quantity I am replacing with sigma y square into the exponential term e power minus y minus my whole square divided by 2, can write in the sigma y square, 2 sigma y square. This is the statement he is asking. What he is asking? Show that the linear transformation of a Gaussian random variable is produce another Gaussian random variable. For this, we are consider the linear equation is y is equal to ax plus b. From this equation, we are finding the two values. One value is x and second value is the derivation of x with respect to y. X quantity is, we are obtaining x is equal to y minus b by a, and then we can differentiating this equation on both sides with respect to y. From this quantity you can obtaining the dx by dy is equal to 1 by a. Why you can doing this one? We are having that one relation for monotonic transformation. The monotonic transformation formula is fi of y is equal to fx of x into modulus of dx divided by dy. By using this formula, we can able to finding the fy is the fy of y quantity. Here, in this formula, our required values are the density function is required. He is given any density function, directly can take in that. Otherwise, he is not given that. What is the information is available in this problem, we can use it. Here, in this problem is mentioned the Gaussian random variable. For Gaussian random variable, already we know that the density function is fx of x is equal to 1 divided by square root of 2 pi sigma x square into e power minus x minus m whole square divided by 2 sigma x square. In this formula, you can just replacing the x value, just you can keep the y values. X position can be replacing with y terms. That one I can do here. And then I have to replace in the quantity of dx by dy is 1 by a. I had to substituting in this one. Finally, I had to simplifying this entire equation. I had to got these values in terms of y. For our simplicity of representation, I have to consider some assumptions. Those are this quantity. What are the quantity is having is a square into sigma square y minus b by a. This quantity I am consider the sigma y square. Similarly, I have to take that the b plus am quantity, it is a mean value of y. Then you can comparing these two equations is fx of x and fy of y, both quantities are similar. You can observe this each and every term, both are having the similarities. That's why you can proving that the linear transformation, otherwise you can take in the linear transformation of a Gaussian random variable is producing the another Gaussian random variable. Okay students, coming to another example problem. Here you can see this example x, y are random variables related by y is equal to 3x plus 6 and x is 0 mean random variable with the variance is 2. Find the variance of y. In this problem he is given that two random variables x and y, and also he is given on equation y is equal to 3x plus 6. After that he is mentioning the mean value of random variable x is 0 and variance is 2. He is asking find the variance of y. First of all, you can write what is the given data is mentioning in this problem. First I am writing the given data. The given data is random variable x, random variable x, mean. The mean we are representing with x bar or expectation of x. The quantity is 0. The second point is random variable x mean value. Random variable x mean value. The mean value we are representing with, already we are writing the mean value. The second one is the random variable variance. The variance quantity is given sigma x square is equal to 2. These two values is given, and what is he is given the function is a relation between random variable x and y is 3x plus 6. Here you can able to find the value of sigma y square. Sigma y square quantity, you need to find that. Then finding this quantity, you can write in the formula of a sigma y square. Sigma y square is equal to expectation of y minus y bar, y minus y bar whole square, y minus y bar whole square quantity. Here you can just keep the quantity of y here. What is the y value? Expectation of y value is 3x plus 6 minus y bar is a 3x plus 6 whole bar totally having the whole square. In this you can able to find the expectation value of 3x plus 6. Here I am finding that the expectation of 3x plus 6 value. This is a similar like a linear equation based on the expectation property. Here I am writing 3 into expectation of x plus 6 plus 6. Already is given the expectation value of x is 0. This is already mentioned in the given data. The mean value of x is 0. Thus I am substituting this quantity of expectation x is 0 plus 6. Total value is 6. This is the quantity of this expectation of 3x plus 6 value. Now I am substituting this quantity in this equation. Sigma y square is equal to expectation of 3x plus 6 minus, what is the value you are obtaining for this? Value is 6 totally behind the whole square. Now you can see if any terms is cancelled, you can cancel it, otherwise you can rewriting these entire values. Here 6 and minus 6 both are cancelled. The remaining quantity is expectation of 3x whole square. This is the quantity is available here. Now you can applying the expectation on this one. Expectation of, can first applying the square, the 9x square. Now you can writing 9 into expectation of x square quantity. Here expectation of x square quantity is representing the second moment of random variable x. Now we can able to finding this quantity. How to finding this? Already we know the variance value of x. By using this you can finding the expectation of x square value. Here this equation I am writing here. Sigma x square is equal to 2. Sigma x square is equal to 2. Already we know that the variance and first moment and second moment is having one relation. The relation we are writing, sigma x square is equal to m2 minus m1 square. How to write in the m2? The expectation of x square minus expectation of x whole square. In this relation already we know that sigma x square quantity is 2 and we required value is expectation of x square. Now already we know that expectation of x value is 0. From this we can say that the expectation of x square quantity is 2. Now you can substitute in this quantity in this relation, we can obtain the expectation of y square. Here I am substituting this quantity is sigma y square value is 9 into 2, the value is 18. Now I can writing here the variance of y is equal to 18. He is giving the problems in this model, he is just given the one random variable mean and variance. He is asking you can find another random variable variance and mean. When how to give the problems in this model, you can do this procedure. Coming to the another example is relating to transformation technique. In this one, he is given x is a Gaussian random variable with mean is 0 and variance is 1. If y is equal to e power x, obtain fi of y. In this model is also is given that the clue is a Gaussian random variable. What is the procedure you can following in the last example? The same procedure you can following here. Here I am writing the given data. The given data is x is Gaussian random variable and the x is having the 0 mean. X is having mean value is, the mean value we are giving the notation is mr x bar is equal to 0. And second one is the random variable x is having a variance. The variance is sigma x square is equal to, the value is 1. Value is 1. But is giving the function of y is equal to e power x. Y is equal to e power x. It is an equation. From this equation, first of all, you can write in the x value, then you can differentiating the x quantity with respect to y. What is the quantity you can able to find that? You can write in here. First step, I have to do that x quantity. From this relation, x value is, you can moving this exponential to y position, you can writing logarithm. You can writing the logarithm is a logarithm of base e, here y is a quantity of x. Now you can differentiate this value with respect to y on both sides. You can apply the differentiation on both sides with respect to y. You can writing dx divided by dy is equal to the log differentiation. We are writing 1 by y. 1 by y. Now you can using the monotonic transformation formula, you can changing the x random variable to y. Now here I am writing the fi of y is equal to fx of x is a modulus of dx divided by dy. It is a basic formula. In this one we require density function. Already we know that the Gaussian density function fx of x is equal to 1 divided by square root of 2 pi sigma x square into e power minus x minus m whole square divided by 2 sigma x square. By using this density function, you can find in the fi of y. Now you can write in the quantity of fi of y is equal to, you can substituting the 1 divided by square root of 2 pi sigma. The x value is, what is x value? Log of y base e square into e power minus, here also you can write in the x quantity. X quantity is, what is x quantity? Log y base e minus m whole square. Okay, here already is given the mean values of x and variance value of x. First of all, you can substitute those quantities. Here you need to substitute the values of x. X mean value is already given. The mean value of x is m. You can substitute m is equal to 0 and sigma x square is equal to 1 in this equation. Then the equation can be changing to 1 divided by square root of 2 pi into sigma x square value is 1 into e power minus x quantity. What is x quantity? Already we know that x quantity from this value. First of all, you can substitute in the mean quantity is 0 whole square divided by 2 into 1. From this one you can write is 1 divided by square root of 2 pi into e power minus x square by 2. This quantity is representing of fx of x when mean value is 0 and variance is 1. Now you can finding the quantity of fi of y. Fi of y is equal to the density function is 1 divided by square root of 2 pi into e power minus x square quantity. What is x square quantity? Already we are having the logarithm. Log of y base e whole square by 2 whole square by 2 into, what is the quantity of dx by dy? The value is a 1 by y. The quantity is 1 by y. We are obtaining that. Now you can simplifying these quantities is a 1 divided by square root of 2 pi. Here logarithm value whole square by 2. This is the final value we are obtaining from this x function.